Hello, Algebra 1. This is Mr. Kinesic. I'm down here in the bottom right corner. I'm located in my office today. I'm going to hope your families everyone's are doing all right. If my dog starts barking, I apologize, but today I'm here to help you guys learn how to solve quadratics. We're going to have irrational solutions, so we're going to be dealing with some square roots. I do plan on showing you guys how to actually use your calculator as well to cheat your way maybe through some of these answers, but you guys do need to know how to do these by hand. So I'm going to show you how to do it by hand, but I'll also show you guys how to use the calculator. Not to mention, I'll also show you guys where you could actually download this free calculator for 90 days. So I'll make sure to put the link in here. So before we actually begin today, the first problem I'm going to give to you guys: square root of 2 plus the square root of 3. I want you guys to take a little time, kind of think about it, and what you guys think the final answer is. Now, if you have a calculator, you could definitely type these into the calculator, then you'd be able to tell me an answer. But how many of you were telling me that the answer was the square root of 5? It's probably a couple of you. But I have bad news. It is not the square root of 5. These square roots you cannot combine together. And to further prove my point, I'm actually going to show you guys on here, where I can actually type in the square root of 2. Now, if you're ever inside a square root, we just hit the right arrow to get out of it, plus the square root of 3. 3.14642, so on and so forth. But let's type in the square root of 5. As you can see, these answers aren't equivalent to each other. That's why the square root of 2 plus the square root of 3 does not equal the square root of 5. They are not equivalent. The real way to kind of think about this is really you have two things that are different, where it's like you have an x and then you have a y, and you can't combine those together. We can combine certain things together that are similar to each other. For example, like 2 plus 3, we can actually combine together, say it's 5. 2x plus 3x, we can combine together and say it's 5x because they're both the same inside. But then if you're dealing with x plus y, you can't combine it. They're two different variables. They are not like terms. The only time we can combine things is when the roots inside are exactly the same. So like 2 square roots of 2 plus 3 square roots of 2 is 5 square roots of 2. Now, we could have a whole nother lesson talking about this, but we're not going to be focusing too much on that. What I really want you to know is that our answers are going to look like these. We're going to actually have two answers for all of these, similar to what we did like 2 lessons ago, where if you were to look at this one right here, we have 3 plus the square root of 2 and 3 minus the square root of 2. We can't combine them together. They're not the same numbers. They don't have the same roots. 7 plus 3 square roots of 5 and 7 minus 3 square roots of 5. Notice you can't combine them together. I even wanted to show these examples as well. Yeah, you guys can look at this and you can say oh, they're both 8. You can't combine them still. The reason being is really this is saying you have 8 plus then you have 8 square roots of 2 keeping added and added together. I'm sorry, my handwriting is going to be a little atrocious. We're working on this little software. So you can't rewrite it. You just leave it like this. No matter what, the only way you can combine things is if you have the same roots with them. Same idea here, 5 plus 4 square roots of 5 and 5 minus 4 square roots of 5. This is a 5, and yeah, that's a 5, but this is a square root of 5. You can only combine square roots of 5 with square roots of 5. That's why we leave these separated. So now, let's get into solving. So in solving, you guys are probably noticing, what the heck is this writing up here in the top left corner? Well, in solving an equation, you have to do the reverse order of operations. It's instead of evaluating where we use the order of operations, we're solving, so we have to go backwards. So what we have to do is first we're going to look for subtraction and addition, get rid of those first. Next, we're going to get rid of any divisions or multiplications, then get rid of any exponents, and then finally, in the last step, we get rid of our parentheses. So if we were to look at this problem, I usually like to draw a line right here, so that way I know whatever I do on one side, I do on the other. Perfectly straight line, isn't it? But the first question I got to ask yourself is do I see any subtractions or additions to get rid of? It's okay, that's negative 2x plus 3 squared plus 36. All right, I see two additions, but which one do you get rid of first? Well, this plus 36 is on the outside, and this plus 3 is inside the parentheses. So that's why I get rid of it last. So my first step here, subtraction and addition, I'm going to subtract 36 on both sides. So I have negative 2 x plus 3 squared equals negative 36. So I got rid of my subtraction and addition that was on the outside. After that, do I see any multiplications or divisions? Well, that's negative 2 times x plus 3 squared. So what I need to do is get rid of that negative 2 on both sides by dividing both sides by negative 2. So now I'm left with x plus 3 squared is equal to 18. So now to actually go about solving this, that x plus 3 is inside those parentheses. It's locked up. You got to let them out. In order to let them out, though, we got to get rid of this exponent. But to get rid of that exponent, our third step in most equations, we have to do the square root. Now, if you hear any barking, that's my dog. His name's Bo. But if you were to look at this, the square root of 2, or where I square root both sides, the square root of 18, well, that's just the square root of 18. It's a decimal that repeats itself. But the most important part, whenever you square root both sides, is you do plus or minus. No matter what, you should always be doing a plus or minus sign whenever you square root both sides. But in the previous lesson, what we talked about was the square root of 18 and other numbers, we can break them down. The square root of 18, what we like to do is think about perfect squares like 1, 4, 9, 16, so on and so forth. But you can just kind of break this number down. It's like, well, if I think about this, it's 9 times 2. Well, 9 is a perfect square. It's a square, it is known as 3 squared because 9 is really 3 times 3. So I can actually rewrite the square root of 18 as 3 square roots of 2. So now, instead of writing the square root of 18, we're now going to write 3 square roots of 2. So now I have x plus 3 equal to positive and negative 3 square roots of 2. Now from here, some teachers like to turn this into like two separate problems where you have x plus 3 equal to positive 3 square roots of 2. And then you also have x plus 3 equal to negative 3 square roots of 2. So for our last step, in order to solve for x, we're back to, doing the reverse order of operations. We subtract 3 on both sides. Now from here, yeah, this is negative 3 and that's 3, but notice they're not the same kind of roots. This is like a positive 3 square roots of 2. So what I'm going to do is say the final answer. We like to write our whole numbers first, and then our rational parts second. So we can say our final answer is negative 3 plus 3 square roots of 2. And x equals negative 3 minus 3 square roots of 2. Now, I'm really happy with myself. I haven't used the eraser feature so long. But let's talk about this. We could also write these as decimal answers. To do that, we're going to have to use a calculator. I'll make sure to include a link for this so you guys can actually add this. We can do negative 3 plus 3 square roots of 2. And then I can do the same question. Negative 3 minus 3 square roots of 2. Notice I just hit the up arrow twice, hit enter, copied it down. So my final answers are 1.24 and negative 7.24. We got a little delay going, but you know what? We're going to get through this. So that's one way you guys can actually solve your questions. I want to also show you guys how you can solve this with the calculator, but I want to make sure to be mindful of you guys' time. Make this about 15 minutes. So I'm going to show you how to solve all these here, and then I'll make another video explaining how to solve them on the graphing calculator. So, next question. Draw my line. Ha, getting better. It's more straight. We have x minus 2 squared divided by 3 minus 21 equals negative 3. First step, okay, do I see any subtractions or additions? Okay, I see 2 subtractions, but that's inside, so I get rid of that later. So I have to add 21 to both sides. So I now have x minus 2 squared over 3 equals to negative 3 plus 21 is 18. Okay. Next, I got rid of my subtractions and additions. I now got to look and see if I have any multiplications or divisions. It's like, okay, I'm being divided by 3, so to get rid of a division by 3, I multiply both sides by 3. So I now have x minus 2 squared equals 54. Next step, exponents. Remember, it's locked up. You got to let them out. In order to let them out, we square root both sides. So I now have x minus 2 equal to the square root of 54. I hope some of you guys are yelling at your screen, but Mr. Kinesic, you forgot something. Yeah, I did. I want to make sure you guys are yelling at me a little bit, that you guys actually remember that you have to put the positive and negative of the square root of 54. Now let's talk about that square root of 54. 54 breaks down into 2 numbers. You can think about any numbers you want. Me personally, I always like to think of perfect squares. It's 9 times 6. 9 is a perfect square. That's why I can rewrite it as 3 square roots of 6. The way I also like to do these is if I look at this, 9 is 3 and 3. 6 is 3 and 2. If you find yourself having a pair of numbers, it comes outside the square root. If you have numbers that don't have pairs, they stay inside and you multiply them. So 3 times 2 gives you the 6. So now I'm going to rewrite this as x equals positive and negative 3. Oh, I have to use my eraser feature, of course, making mistakes. It happens. So I have x minus 2 equals positive and negative 3 square roots of 6. Now, I wanted to show you guys, you could definitely break this down to 2 separate parts, but we can actually just know it's like, hey, I got x. To get it by itself, I need to add 2 to both sides. So I can say x, I add 2 to both sides. I can say it's 2 plus or minus 3 square roots of 6. And really what you're saying is you have 2 different answers. The answers are 2 plus 3 square roots of 6 and 2 minus 3 square roots of 6. So you have 2 different answers. It's just another way to kind of show your steps. Some of you like this where it's a little bit simpler. Some of you might like it where you have to show the 2 different lines coming off of it. I do want to make sure to show you guys the decimal equivalency answers. So we can type in 2 plus 3 square roots of 6. Get 9.348. My video is blocking the rest of the numbers. And then we have 2 minus 3 square roots of 6. I have my letters turned on. Let's turn that off. Now, most of the time for Algebra 1, we usually like to include 2 decimal points. Some other classes usually include 3. For AP Calculus, the exam, they make sure you include 3 decimal points for all your answers. But we're just going to include 2. So I see 9.348. Well, that 8 rounds that 34 to a 35. So we can say it's 9.35 and negative 5.35 are our final answers. I occasionally forget numbers. It happens. I want to show you guys 2 more. And then you guys can be done with this video, rewatch it however you want. But these are some good problems to see. This next problem, Hope you guys are excited for this one. It's a lot of them, they mostly stayed the same, where it's mostly just like, okay, do I see any additions or subtractions, any multiplications or divisions, so on and so forth. So even just looking at this problem, let's just kind of break it down, take a look at this and see if we can actually figure out the steps. It's like, okay, first steps. Do I see any additions or subtractions? Yeah, I got 2 of them, but this one's inside, so this is the first thing I'm going to get rid of. The next thing I need to get rid of, any multiplications or divisions. Well, that 3 is multiplying on the inside, but this one's right here is multiplying, so we got to get rid of that one second. Next, since those are inside the parentheses, in order to get to those, I'm not going to have to get rid of that exponent. So that's the third thing you have to get rid of. Now, if you're to look at this, I have 2 and 3x, so it's like, okay, I got to get rid of addition first, and then that 3x will be the last thing. So this problem really's got 5 steps, you think. But let's actually go through it. So first thing we said we were going to get rid of, I'm going to add 5 on both sides. So I have negative 3x plus 2 squared equals 9 plus 5. Well, 9 plus 5 is 14. Next step, that negative sign is multiplying, so I have to divide both sides by -1, because it's like that invisible 1 right there. So when I divide by -1, I'm left with 3x plus 2 squared equals -14. And then we square root both sides. And then you're like, okay, square root of -14. I want to show you guys this. The square root of -14. Hopefully my calculator's in the right mode to where it works. Bang. Non-real answers. You can't square root of negative. So if you were to actually look at this, you can tell me there are no real solutions. But Mr. Knezek, shouldn't you just say no solutions? Let's not go there. We're just going to say there's no solutions. You can say no real solutions, but there's a way to kind of do these, but that's algebra 2. We'll get to those another time. Finally, the last question we're going to do with you guys. Okay. Any subtractions, additions, multiplications, or divisions, exponents, and parentheses. Okay, so I want you to just look at this side right here on the left side. First, I'm going to draw that line. And yes, I'm going to wait for a second. It's like, okay, which of these things should I get rid of first? Then what should you get rid of afterwards? After that, what should I get rid of? And finally, what's my last step? So hopefully you kind of said that to yourself and you're like, okay, subtractions, additions, that's inside parentheses, so get rid of that later. So I'm first going to add 50 to both sides. So now I have 2/3 x plus 1 squared equals 42. Next, I got 2/3 x plus 1 squared. Now I saw Miss Robinson's video already, and she kind of explained to you guys you can do this in 2 steps, or you can get rid of it in 1 step. If you have my class, I've always talked about when dividing fractions, multiply the reciprocal, where it's like, okay, to get rid of 2/3 that's multiplying, we're just going to multiply it by the reciprocal, which is 3/2. If you wanted to do it in 2 steps, you could be like, okay, I'm going to multiply by 3, then divide by 2. So now you're left with x plus 1 squared equal to. Now, I'm going to do this my way. Some people like to multiply first, but those people are like dealing with bigger numbers. I like to divide first. 42 divided by 2 is 21, and then 21 times 3 is 63. So you guys can also see the little cheat on how to do this in your calculator. We can do 42 times. And if you hit alpha y equals, you can actually set up numerator and denominators. So all I just did, so you guys can just see that again, is alpha y equals. And just hit enter, it'll set that up for you. You do 3/2. Gotta move my face, 63. So back to math. 63. I square root both sides. square root of both sides. Apparently, I like multiples of 9. I just kind of picked these problems at random, but you'll understand that in a second. X plus 1 is equal to positive or negative square root of 63. But we have to keep in mind that you guys should be looking to simplify these square roots. For the square root of 63, square root of 63 is 9 times 7, or we can say it's 3 square roots of 7. So we now have x plus 1 is equal to positive or negative 3 square roots of 7. Final step, if you want to do it where you rewrite it 2 separate times, x plus 1 equal to 3 square roots of 7, and x plus 1 equal to negative 3 square roots of 7, you're more than welcome to. That's an ugly looking 3. Let's see if we can fix that a little bit. But I like to just do it right here where I can see I have 2 answers where it's x equals negative 1 plus and minus 3 square roots of 7. And make sure you guys can actually see what it would be in the decimal equivalency. We can see it's negative 1, pardon me, negative 1 plus 3 square roots of 7. So 6.94, because that 7 rounds it up. Hit the up arrow twice, hit enter, negative 1 minus 3 square roots of 7, and negative 8.94. So 6.94 and negative 8.94. So that's the main idea of like these solving questions. It's mostly solving them. Once you get to that square root part, make sure you simplify the square root. Now I do want to show you guys how you can use your calculator to solve these.